Okay, so when we had a look at the binomial expansion last week, what you will have hopefully picked up on in the formula is that we're expanding 1 plus some sort of x. It might have a coefficient in front of it, so we could call it ax perhaps, and then we have a negative or even a fractional power. What we need to be able to cope with though is some examples similar to this one here, where you might end up having a number at the start of the bracket on the inside which isn't quite 1. It's quite simple to deal with, so we'll just get straight into an example. Okay, so if I was asked to expand this, up to the first sort of 4 terms, then obviously you'd start off by rewriting this as your 4 plus x to the power of a half. You realise that you've got now a fractional power, and so we're going to have to go back to using that formula that we met the other day. What you've also got here though is something slightly different to that formula of the day, in that we have a number 4 at the beginning of our bracket. So the way that we would have to deal with that is to take out a factor so that inside the bracket was in the form of 1 plus x something, because otherwise that formula is not allowed to be used. So if I take the 4 outside of the bracket, I'll be left with 1 plus. Now inside the bracket it would have to be an x over 4, all to the power of a half. However, with the 4 being inside the bracket, it does have this power of a half being applied to it. So when we take that out as a factor, we must also keep that power of a half on the outside too. So here we are. Now then we will have, so the 4 to the power of a half is 2, and for the remaining section we can now use that binomial expansion formula. So I've written the formula up here for us to be able to use. So let's just go through and just identify our parts. So n is the power being applied, and in this case that's a half. Our x in this case is being divided by 4, so we have to make sure that we substitute that every place where we see the x. So going through, I wanted the first 4 terms, so I'm going to have 1 as my first term, n is a half being multiplied by x, so that's x over 4. Then I would like my next term, so that's n, which will be a half, n minus 1 is minus a half, all being divided by 2 factorial, and then that is going to be x over 4 squared. And then the next one is a half, minus a half, minus 3 over 2, all over 3 factorial, and then that's x over 4 all to the power of 3. Okay, now for us to evaluate. So here we have it, the expansion up to the 4th term. Now, bearing in mind that the 4 that we had at the beginning, that was to the power of half, has become this 2, and so to finish off the question we just need to multiply every single term there by the 2 as we're going through. So we will get 2 plus x over 4, okay, because the 2 and the 8 will cancel there, minus x squared over 64, plus x cubed over 512. Yep, so that's that question done as far as the expansion goes. Now, if we're going to get one of those questions where it's talking about, again, when is the expansion valid, that's also, a very popular question. So when is it valid? And we know that we have to go to that x term, and we've got to consider it once that coefficient's been taken out. So I've got that 2, 1 plus x over 4 to the power of a half. So it's this section here that we look at in terms of that modulus. So the modulus of x over 4 less than 1 is when it will be valid. So if I wanted it just in terms of x, I'd have to multiply through both sides by 4. So when x, or the modulus of x is less than 4 there, is when the expansion is valid. And just as a quick recap, that means, that x can be between 4 and minus 4. And there we have it, example done. Okay, so I'd like you to have a go at doing this question, and I'm bringing it in to the next lesson. So again, I want you to find the first 4 terms of the expansion, you need to make sure, obviously, that you're going to take out this factor of 2, because it must be in the form of 1 plus something x. And then I'd also like you at the end to tell me when is it valid, the expansion that is. Okay, so I'll see that in lesson. Bye.